folks, Jenny, your instructor here. Let's go over some of the things you just learned in section 1.3 and 1.4 because you need to start memorizing a few things in order to apply them to section 1.5. And I want to be clear what you need to memorize and how to move forward. So that's what this video is about. And then we end with a bunch of examples from section 1.5 and doing those. Okay, ready to get started? Let's go. Okay, so let's walk back to section 1.3 and remember that in 1.3 you were introduced to the definitions of the 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent, and they are shown here on this slide. So within these definitions, there's some interesting relationships. That is what we want to explore in section 1.4. So let's first observe that y over r becomes r over y for that row. So sine is defined as y over r, but cosecant is r over y. This table is arranged in a specific way. In each of these rows, the fraction is flipped. When we flip a fraction, we call that the reciprocal. So sine and cosecant are reciprocals. Cosine and secant are reciprocals. Tangent and cotangent are reciprocals. So that's what section 1.4 is about, is pointing out those relationships in the definitions. Now, these reciprocal identities do need to be memorized, as it does say that in your book, and I agree, you should memorize these, because once you commit them to memory, then they become evident when you're looking at a new problem. So let's look at these. We've got cosecant equals 1 over sine, and that is saying a mathematical relationship. And that relationship says that the two functions are reciprocal to each other. So there it is stated there. We'll be using this equation really frequently. Over on the right, we've got the same statement, but it starts with sine and says that sine and cosecant are reciprocal as cosecant and sine are reciprocal. They're reciprocal to each other. So these pretty much say the same thing. They're saying the reciprocal relationship, but in a different way. Same thing across this row, and that is that these are really saying the exact same thing, that secant and cosine are reciprocal, and cotangent and tangent are also reciprocal to each other, and it is stated in 2 different ways. So let me be clear that the relationships on the left are more useful and more used, shall I say. They're more used than the relationships on the right. And why would that be? We really want to commit these to memory because we're going to be using them a lot more than the ones on the right. Why would that be? Let me go back to this. Now, when we look at this chart here, I've organized it in a very specific way. The rows have the reciprocal relationship as we just were saying, but also on the left here, these 3 functions, sine, cosine, and tangent, those guys are really the stars of the show when it comes to trigonometry. So what we want is for these guys right here on the right, we want them to point back to the stars of the show, sine, cosine, and tangent on the left. The way that they point back is through the reciprocal identities. Notice that cosecant right here in this box can become sine and can be replaced by 1 over sine of theta. So an equals sign, you might read it more frequently in this class as may be replaced by, and that is maybe not something that you're used to reading the equal sign to mean, but in this class you'll be using that meaning a lot. So what does this say? The first equation, cosecant equals 1 over sine. It says that cosecant of theta, which is not one of the stars of the show, so this is over on the right, and we don't really use cosecant so much, can be replaced by 1 over sine of theta. secant of theta can be replaced by the expression 1 over cosine of theta. Cotangent of theta can be replaced by 1 over tangent of theta. Now this really comes into play in section 1.5. The can be replaced by, that action is actually what you're doing in every single problem in section 1.5. Let's look at new relationships called the ratio identities. Furthermore, what we can say is that tangent has a relationship to sine and cosine as a ratio. Now over here on the right it says why is this true? So sine over cosine, if you'll remember their definitions, sine is y over r. Sine is replaced by y over r. Cosine equals x over r. So cosine is replaced by x over r. Notice I'm already using that meaning of equals as can be replaced by when I'm walking through this proof. Now y over r over x over r, how does that become y over x? Well, through a little bit of algebra. Y over r divided by x over r. The division becomes multiplication and you take the reciprocal of the second fraction. So our r's cancel and that is how you get y over x. But y over x by definition is tangent. Well, this is very interesting that both tangent and cotangent can be replaced by something about sine and cosine. I'm going to go back to my statement over here that said, hey, these are the main players of our entire class. And now I can boil it down to actually two of the main players, sine and cosine. Sine and cosine are the main players of the class because we just found a bridge from tangent to point back to sine and cosine. So what I'm saying is every function can be written in terms of sine and cosine. So here we are, because down here you can walk through that the same way that I did the one right above it. So the last identity from section 1.4 that I need you to know is the Pythagorean identities. When you square cosine and add it to the square of sine of the same angle, the angle has to match. It always equals 1. And how does that work? How do you get from this left to the right? Well, you just simply subtract either sine squared theta or cosine squared of theta to 1 to get the one or the other. So if I subtracted sine squared of theta from each side of the equation, I would get the first equivalent form. Okay, that is that cosine squared of theta equals 1 minus sine squared theta. If instead I subtracted cosine squared to each side of the equation, so let me just walk through that. Here, if I subtract this from each side, then these guys cancel off, and I'm left with sine squared theta equals 1 minus cosine squared theta, which is the second one. So these are equivalent forms because you can just algebraically manipulate the first identity to get the other two. Your eye has to pick up on these identities, so they need to be memorized. Otherwise, your eye won't pick it up and know what you're looking at. So make sure that before you proceed to section 1.5, that you get familiar with all of these identities. Now, I won't ask you to memorize these other two that are in the table 3 in your book. I won't ask you to memorize them because they can be derived from all the ones we previously did. So don't worry about them. You can if you want. You can totally memorize them and use them if you want. But I won't ask you to memorize them. All right. So in section 1.5, we need to know the reciprocal identities. We need to know what were the other ones, the ratio identities. And we need to know that Pythagorean identity with sine and cosine at least. Okay, so then you're good. All right, let's look at a few examples. In the first example, it says simplify 1 over cosine 1 over sine to a single trig function. In section 1.5, not only are you dealing with identities, but you are also dealing with algebra. So we want to think about this right here, the cosine of theta and the sine of theta, as a single variable. Suppose I had this back in algebra and you are asked to simplify this complex fraction. It says 1 over a over 1 over b. So 1 over a is a fraction. That big divide line here is a division. And then I write the bottom. Okay, so this becomes 1 over a times, so division becomes multiply by the reciprocal. And finally, you multiply across the top and you multiply across the bottom. And in algebra, this would be most simplified. What do we do here in trig? Now we have 1 over cosine of theta. And I want you to look at cosine of theta and sine of theta as if they were single variables, just like that's A and that's B. The process is identical to algebra at first because we're not dealing with trigonometry in the first steps. So in the first step, we really just imitate what we did above, and then we transition to trigonometry in the last step. But here we go. So we're just imitating what we did above, and we use the algebra that we know, and then multiply across the top and multiply across the bottom. Well, if I was just doing algebra, then I would be done, but I am in a trig class. This is where your memorization comes into play. Sine over cosine is a ratio identity, and it equals tangent. So that's a single trig function, and now I finished the problem. Let's look at example 2. So it says write in terms of sine and cosine, then simplify. So cosecant, do we remember what it is reciprocal to? The may be replaced by is very key here. That's what the equal sign means in the context of identities. May be replaced by. It may be replaced by, so I put parentheses around it and simply replaced cosecant by 1 over sine. And cotangent of theta may be replaced by what? Cosine over sine, right? Multiply across the top and multiply across the bottom. So this right here is the way we say the square of that function. The square of the function, the 2 always goes in between actually the n and the theta right up here, and you don't put it after the theta because that actually means something different. All right, so I've gotten as far as I can get. I can't really simplify this any more than it already is, and so I am going to box it up and say I'm done. Let's do another example. Again, we're going to write in terms of sine and cosine and then simplify. So secant, what can it be replaced by? By its reciprocal, 1 over cosine. Cosecant can be replaced by 1 over sine. Okay, so I just did the trigonometry that I have memorized, and I used the equal sign to mean can be replaced by. Now the next thing I want to do is algebra, and I want to treat the functions as if they were variables. So now what I will do is I will multiply by the reciprocal instead of dividing, and then I multiply across the top and I multiply across the bottom. You would recognize this as tangent, so I'll just write that is the most simple way to express your final answer as a single function. So we are done with that. Okay, the next one again is right in terms of sine and cosine, remembering that sine and cosine are the stars of the show, so you should always be trying to get back to sine and cosine. So let's remember our ratio identity, and it puts us back in the sine and cosine pocket. And over here, cosecant, let's replace that with its reciprocal, identity 1 over sine. Now what we notice is that we have two fractions that are being subtracted. And we have to remember from our days in algebra that a common denominator allows you to subtract fractions. So we already have a common denominator, and we simply then put the common denominator below. And above here, cosine of theta and 1, we can show symbolically that they need to be subtracted, but you can't really do anything more to this problem other than to say that the numerator is a subtraction, the denominator is sine of theta, and we're done. The next problem deals with denominators that are not identical. We have to find a common denominator. So in algebra, you may have encountered a problem like this, and you're asked to add a couple of fractions, and we remember that we can only add fractions with common denominators. So how do you do that when your denominators aren't at all alike? We multiply by the other guy. Now I have a common denominator, but what I do to the bottom is the same thing that I do to the top, right? So I write the top as it was, but I'm remembering that what I do to the denominator, I do the same thing to the top. And now we can simplify. So we'll have b times b, otherwise known as b squared. We're going to add on the top of the other fraction. Now the common denominator is ab. All right, so that would be our process for algebra, and trigonometry has a layer of both algebra and trigonometry going on. So let's look at this one. Again, we need to add two fractions, and they do not have a common denominator. So what I will do is write the denominators here. I'll write the denominators, and they're not at all in common. They got nothing in common. So what do? Well, I simply take the other guy and I multiply it to the top and to the bottom. And for this one here, the other guy, the top I'll rewrite. And this looks very much like the process that we just did with algebra, because really that is all we're doing, is a little bit of algebra here. So the top, remember how to write the square? You put it in between the function and the angle. And over here, 1 times sine, you would just simplify as sine. And on the bottom, what we have is cosine theta, sine theta. Okay, and that completes then our problem. Remember that this time, your homework is paper homework, and you can find that on Canvas. Okay? Super duper. All right, see you guys later, and good luck with this.